Hey guys, today we are going to be looking at lesson 9.6, the converse of the Pythagorean theorem. So what is a converse? A converse is when you take a statement and you switch the hypothesis and conclusion. For example, if the statement says if P then Q, the converse would be if Q then P. So for the Pythagorean theorem, our Pythagorean theorem states if we have a right triangle, then a squared plus b squared equals c squared. So if we use the converse of that, if a squared plus b squared equals c squared, then we have a right triangle. Okay, so today our goal is to understand the converse of the Pythagorean theorem, be able to explain the converse of the Pythagorean theorem, and identify whether a triangle is a right triangle, either given three sides, or if the triangle is on a coordinate plane. Okay, so looking at this first example, we're given three sides. So to determine whether it is a right triangle, we are going to plug it in to our a squared plus b squared equals c squared. Remember when you do that our c squared is always the largest side. Here we don't have a right angle to go across from because we don't know that it's a right triangle. Okay, so if I evaluate now, I could use my calculator, right? 9 squared, 40 squared would be 1600. 41 squared is 1681. All right, so 1681 equals 1681. So, yes, this is a right triangle. All right, same idea for B, right? My smaller sides here are 12 and 18. My longest side is 24, so I evaluate. Uh, 324 and 144 would add up to 468, which does not equal 576. So this is not a right triangle. All right, same idea for these next two. Feel free to pause the video here to try them on your own. All right, so same concept, right? My two smaller sides here are 20 and 21. My larger side is 28. We use a calculator. Um, 841 does not equal 784, so this one is not a right triangle. All right, same idea for number two, right? If we plug those in, my two smaller sides are 0.75 and 1. My longer side is 1.25. Oops. So this one, since these two sides are equal, this is a right triangle. All right, so what happens now if we are looking at an example where a triangle is on a coordinate plane? Okay, well, on the coordinate plane, the problem right now is that we don't know all of the side lengths, so we're going to have to calculate that, right? So I can see this side length is, BC is 5, right? But what is AB and what is AC, right? I need to find those. So AB, I can see is made up of sides 2 and 4. So c squared equals 2 squared plus 4 squared. All right, so I get c is the square root of 20. All right, same idea, right? So this side was root 20. All right, so if I look at side AC, my sides here are 1 and 2. So C is the square root of 5. All right, now that I have all my pieces plugged in, now I can decide whether this is a right triangle. I know that the square root of 20 is between 4 and 5, and 5 is bigger than that. So I know that 5 is going to be my hypotenuse when I plug it in. So a square root and a squared cancel, so I get 20 plus 5 equals 25, which is true. So yes, this one is a right triangle. All right, same idea here for 3 and 4. Feel free to pause the video to try those out. So I'm going to go ahead and draw my triangle. So -4, 0 is D, -2, 3 is E, and 1, 0 is F. All right, the nice thing here is, again, I know one of my sides already. DF, I can count that, and that is 5 units long. So I can calculate DE. So if I make my little triangle here, right, DE is 2 by 3. All right, so I know that DE is square root of 13. All right, I can look at EF, and that triangle is a 3 by 3. So C is the square root of 18. And now I can plug these in to the Pythagorean theorem. Again, I know that 5 is my largest side. So we would get square root of 13 squared plus root 18 squared equals 5 squared. So 13 plus 18 equals 25. 31 does not equal 25. So no, right? That is not a right triangle. All right, same idea for problem 4. All right, so I can plot my points. 4, 1 is J. 1, -3 is K. And -3, 0 is L. All right, here I don't know any of my sides. That's okay. Let's draw our little triangles in here. So this is a 3 by 4. This one is a 3 by 4. That's nice. So we know that KL and KJ are going to be the same. And then that's a 1 by 7. All right, so I know we just said KL and KJ, right, are both 3 by 4s. So if we find that, right, C squared equals 3 squared plus 4 squared. So 9 and 16. That would be 25. Square root of 25 is 5. All right, so I know both of those sides are 5. I'm going to switch colors there, actually. All right, so now we can find LJ is 1 by 7. All right, and now that we have our sides, we can plug those into the Pythagorean theorem. So if we do that, we get 5 squared plus 5 squared equals square root of 50 squared. So 25 and 25 equals 50, which is true. So yes, that is a right triangle. And here I knew that square root of 50 was my hypotenuse because square root of 50 is larger than 7, right? Because square root of 49 is 7, so I knew square root of 50 is larger than 7. So since my other sides were 5, I knew square root of 50 was my hypotenuse. All right, guys, that is it for today. Go ahead and log into Big Ideas and try out those problems.